Hello, and very good morning to you all. Thank you for joining us and welcome to today's DrayTek product briefing on DrayTek Fibre routers. I'm Alex Schuker, CTO at DrayTek UK and Ireland, and joining me today is Amy Hood, one of our DrayTek product specialists who will be your main presenter for this session. So here's the agenda for today. We're talking about fibre broadband in the UK and how it's being rolled out and implemented. Then Amy will look at going over which DrayTek routers are ideal for fibre and detailing some of the key benefits using a DrayTek router with fibre broadband. Then we'll have the Q&A at the end. So if I go on to full fibre broadband, so fibre plans in the UK have kind of been in the news recently with the completion of Ofcom's wholesale fixed telecom market review for the period of 2021 to 26, which looked at what regulatory decisions it should make to promote investment and protect competition in the build of gigabit networks. A separate announcement was the announcement of the Phase 1 delivery plan for Project Gigabit, the government scheme to encourage delivery of fibre broadband to hard-to-reach areas, which are not typically commercially viable due to things like their location. If we look at the summary of the current rollout plans, in this table here you can see the current FTTP footprint, and listed is the current and planned coverage of premises passed in number of millions. The term premises passed means the number of premises that could order a service from the ISP. This is different to the number of subscribers an ISP currently has and reflects their kind of infrastructure footprint. For example, Virgin Media are listed as 14.7 million, but currently have around a little bit more than 5 million active internet connections. Virgin Media's network technically is coaxial cable, but with the rollout of DOCSIS 3.1, this can provide gigabit cable speeds. So it's relevant to include when looking at coverage and the gigabit capability across the country. As we can see, many of the network operators have ambitious rollout plans to expand their FTTP networks, and although there could be some discussion of the likelihood of meeting all of the 2025 targets, it's clear that what the direction of travel is, that we're going to see a lot more fibre in the UK. If we look at where we currently are, so Ofcom in their Connected Nations report for 2020 reported that currently 17% of UK properties are able to order a full fibre connection, and then when Virgin Media is added in, that rises to 27% being able to order a gigabit cable connection, because gigabit cable category includes both fibre and coaxial cable networks. The source for this data is Ofcom, who are the regulator responsible for telecommunications, and they have all of the they receive information on subscribers from all the different operators. So what will 2025 look like? The government's current 2025 target is 85% availability of gigabit capable, so that would include both FTTP and cable. This is kind of reining in on the ambition of the full fibre claims, kind of initially made for full fibre for all. But I think that this will possibly look like something like 60% coverage in 2025, with cable networks making up the difference, so it being a kind of a overall 85%. So what about the remaining? So the big challenge is how to provide coverage for the final 20% of harder to reach properties. These are ones which, due to their location or distribution of properties, aren't commercially attractive to network builders. High density urban locations allow more premises to be covered over shorter distances and a lower cost, but in comparison, lower density areas where the fibre needs to be laid can result in kind of higher cost per premises. The map on the left shows the different regions where the England phase of Project Gigabit is operating. The areas shaded in grey are already covered by existing commercial rollout plans or already have FTTP availability, and the areas outside of this are where the government is considering subsidies to support provision of FTTP. The scheme is dividing up the potential rollout into major catchment areas of around 70 to 150,000 premises, where companies can bid to be appointed as a regional supplier for a specific project. In addition to this, there's smaller projects of 1,000 to 8,000 premises that are awarded to local suppliers who are perhaps specialising in specific FTTP rollout schemes in their area or in communities. The idea is that the project awards will be designed to avoid any overbuild of existing commercial rollouts. And for the first phase, there's 6 projects that will start in the first half of 2022. Each of these kind of are around 30,000 premises each, and in total will cover about 500,000 premises. Also in this scheme is a voucher scheme with 210 million of investment, where people can get a voucher of up to 1,500 for residents or up to 3,500 for businesses from 8th of April 2021. The voucher scheme is quite popular with network builders. The previous scheme had 66,000 vouchers issued at a value of 127 million. So this is kind of encouraging them to it's kind of a subsidy to help with the cost of building the network. And the last part is 110 million to give FTTP to 7,000 rural GPs, surgeries, libraries and schools, which is going to start later in 2021. There's further initiatives in Northern Ireland, Wales and Scotland also to encourage rollouts. So if we go to the next slide, we can see, before I move on to the main part of what is fibre with Amy presenting, just wanted to quickly look at across to Ireland to see how their rollout plans compare. So they've created a national broadband plan to deal with the challenges of connecting rural premises across Ireland that are more commercially difficult. Currently, around 77% of Ireland is covered by plans with Open Air and Zero, the 2 largest fibre builders. They've so far covered 500,000 with Open Air and 374k with Zero, with plans to cover 1.8 million premises in total, which will represent 77%. The remaining 23%, which is just over 500,000 properties, need to be covered by some sort of subsidy. And the plan has resulted in the creation of a new fibre build operator called the National Broadband Ireland, who with state aid will focus on the challenges of providing fibre broadband to rural areas. The current stated plans are 81,000 properties by March 2022, with further surveys and rollout plans to be announced. But the ambition is to complete 23%, the remaining 23% over a 7-year period. The first areas who have been connected so far are Cavan and Cork, where in total 8,000 premises have been added to the network. So it's interesting to look at how that compares. So I'll now move on to pass on to Amy, who will look at more closely at what is fibre and guide you through the rest of the presentation.
Hi everyone, I'm Amy Hood, a DrayTek UK product specialist. And to begin my part of the presentation, I think it'll be good to ask, what is fibre? So in the context of the UK's broadband, you'll get lots of different answers to that question, and many of these answers will be correct despite being different. So to start with, I've broken down the different types of internet connection into their individual parts. On the left, we have the telephone exchange, or ISP end. This connects via fibre or copper to the last mile equipment, which provides connections from a street cabinet. You've probably all seen these big green boxes with vents, which you'll see just about everywhere in the UK, or the big grey boxes, which are usually used by Virgin Media. These house the ISP equipment that connects to your premises. Looking at the connection from the exchange to the last mile, many of these already use fibre. The reason there are many forms of fibre broadband is that it's most easily used as a link in the chain, providing a high throughput link covering a great distance. The last mile, however, from the street cabinet to your office is still often using copper cabling because it's difficult and costly to replace. At this point, ADSL is probably the only type of broadband still in common use that does not use fibre in some aspect. So if we look at these two terms, copper cabling uses electromagnetic signals to send data, and although it's been great for telephone lines, it has serious limitations for high-speed broadband, such as it being susceptible to radio interference, along with signal and power loss as the distance increases. We've mitigated most of these with ADSL, VDSL, and G.fast, but it's fair to say that we've reached a point of diminishing returns beyond G.fast technology. Recent technological advances have made it more economically viable to implement glass fiber optics, which send data through pulses of light transmitted at different wavelengths or colors by either a laser or LED light. This isn't susceptible to radio interference, and it can pass data over much greater distances at much higher speeds. FTTC, or fiber to the cabinet connections, are partial fiber connections, as I mentioned, using an optical fiber to link from the exchange to a cabinet in the street. They boost speeds by making the copper cabling as short as possible, therefore removing the main barriers to broadband performance for as many users as possible. For a good example of this, the main reason that VDSL is faster than ADSL is that it reduces the length in meters of copper cabling, replacing a large portion of it with optical fiber. This shorter copper cable length enables more advanced encoding for higher speeds, and because of this, it's often referred to as fiber broadband, as it's at least partially using fiber. For OpenReach DSL, this typically goes into a VDSL or G.fast MSAN in the street cabinet to have many users connect and share that fiber link using their copper telephone cables to each building with the DSL modem. OpenReach provides the backend network for ISPs like Sky, TalkTalk, PlusNet, and BT, and the same applies to Virgin Media's fiber optic cable broadband. Multiple users typically share a fiber link with coaxial cable going to individual premises. These both provide great performance, especially with G.fast and Virgin Media's latest DOCSIS upgrades, with speeds ranging from 330 megabits to over a gigabit. Copper wiring in the last mile does have its limits though. Speeds beyond 300 megabits may only be possible for some users, with the distance from the street cabinet and bad line conditions becoming major factors in performance losses. Poor quality lines, or in some places aluminium lines, are quite limited in the performance they can offer even with FTTC. So if we use fiber going from the telephone exchange all the way to the premises, we can avoid these issues and go fully up to or beyond gigabit broadband speeds. Another benefit is that full fiber allows for increased or symmetric upload bandwidth. Fiber to the cabinet, or partial fiber, has made sense until now because the cost of implementing the last mile as full fiber is quite high. It can require digging up roads, and running fiber links directly to individual buildings requires a great deal of planning and engineer installation work. As full fiber implementations become more available in more locations, we're starting to see these installed in both homes and businesses. Full fiber is quite complex to implement, and we largely use a technology called GPON, which is Gigabit Passive Optical Network, to share a single fiber line between multiple premises, which uses a passive optical splitter, like a prism, to share the optical signal over multiple fiber strands. The ISP supply their own box, equivalent to a DSL or cable modem, called an ONT, or Optical Network Terminal. This shared data goes to all ONTs connected to the fiber, but only your ONT can decrypt the encrypted data stream sent to it. This gives you around 2.4 gigabits of upload bandwidth to share between all fibers connected to the main uplink, or more with XGPON, which is 10 gigabit GPON. And for upstream, data is sent on a different wavelength, so it can send while receiving on a different channel. Each ONT gets a time slot to send data, giving around 1.2 gigabits upstream bandwidth for all connected lines. The endpoint link that you receive at your premises is 1 gigabit up and down, typically, but this is shared between other points on the main fiber. This is the same as FTTC connections in that the fiber link is shared over many users, giving a contention ratio for the line instead of dedicated, but with much higher speeds and with less contention, with far more capability to improve in future. ISPs like OpenReach will supply the optical network terminal, which will be configured to operate on the network with the required pairing and configuration, the same as a Virgin Media cable modem, for instance. This means that full fiber internet in the UK, where you can plug in your own router, will normally be supplied as Ethernet and it will be rare for fibre ISPs to provide a simple optical link and tell you to just get on with it. One major benefit of this implementation is that the ISP can diagnose faults with the optical network far more easily than it could if the optical network terminal was simply left up to the customer. In the rare instance that you do have a direct fibre optical link, you can use an SFP transceiver module with some DrayTek routers to convert the optical signals into Ethernet. With all of that said about the UK's fibre broadband implementation, I'll now talk about DrayTek's ideal products to use with fibre. So each of these routers is ideal for fibre broadband, with performance options to easily handle gigabit with the Vigor 2927 series, and even faster on the Vigor 2962 and 3910, which I'll detail in a minute. You'll notice that each of these are Ethernet routers, which can load balance one or more Ethernet WAN connection instead of having a modem integrated for one connection, which is beneficial for load balancing because it gives you an upgrade path to any Ethernet modem or connection you want to use rather than a fixed integrated DSL modem, so you can load balance two Ethernets. The Vigor 2962 and 3910 routers are unique in DrayTek's product line in that they have SFP module slots, giving the possibility of direct optical fibre links with a suitable fibre transceiver. So here's a table comparing each of them. The Vigor 2927 series is well suited to networks of 30 to 50 users with 2 gigabit Ethernet WAN ports, one of which is flexible so you can switch it to a LAN port if needed, giving 6 LAN ports in total. It has wireless options available with AC models and the option for an integrated dual SIM LTE modem. So the larger Vigor 2962 and 3910 routers are both rack mountable out of the box, but they don't have wireless integrated. Instead, you can use DrayTek's Vigor AP wireless access points, such as the Vigor AP 960C, for wireless coverage in larger buildings, where multiple access points might be more suitable for the application. The Vigor 2962 caters to larger networks needing more performance with 2.5 gigabit capability. It has 2.5 gigabit Ethernet port to use either as a LAN or WAN, and it has an SFP module slot which is shared with the gigabit Ethernet WAN port, giving 2 active connections for load balancing and 4 LAN ports. The Vigor 3910 offers extremely high performance and is well suited to larger, more complex or multi-tenant networks, providing a mixture of 2.5 gigabit Ethernet, 10 gig SFP Plus module slots, and gigabit Ethernet WAN ports, which can be set up to use either as LAN or WAN ports as needed, giving potentially 11 active internet connections or 11 LAN ports with a single WAN configuration. So there's a number of key DrayTek features that I'd like to cover here, with a focus on performance, VPN connectivity, and network management, as each of these categories can be leveraged to great effect with faster fibre broadband. So I'll begin by looking at the performance. With older routers, having limited routing or VPN throughput was less of an issue because broadband speeds could rarely exceed what was available. But now, with gigabit and faster connections, routing and VPN throughput are an essential metric to look at when purchasing new routers, because VPNs and internet connectivity are starting to make more and more use of these faster connections. Looking at the Vigor 2927 router compared with the previous generation, routing performance for a single WAN improves to make full use of gigabit broadband with VPN capabilities to match. Hardware accelerated IPsec boosts VPN speeds up to 800 megabits, and SSL VPN performance is also significantly faster, providing more capacity and speed for remote dial-in users to make use of. Going beyond the Vigor 2927, looking at the higher-end routers, we can see that performance increases even further, with the Vigor 3910 offering 10 gigabits routing performance in total. The Vigor 2962 provides up to 2.4 gigabits for a single WAN with its 2.5 gigabit Ethernet port, and you'll notice that the total routing performance for the 2927 can go up to 1.8 gigabits with 2 fibre connections. IPsec performance on the 3910 is around 3.3 gigabits, and if we look at SSL VPN, it can achieve 1.4 gigabits of SSL throughput, ideal to handle lots of remote dialing users at once without creating a bottleneck. The Vigor 2962 also offers a very respectable 650 megabits of SSL performance. Again, great for dialing users with fiber to the premises. One other metric to consider is NAT sessions. To a certain extent, this defines how many users can use the router at once. If the router runs out of available NAT sessions, that could stop connectivity for new users, so it's important to over-budget session counts to handle all users. Typically, we'd recommend the Vigor 2927 for around 30 to 50 users, while the Vigor 2962 and 3910 can handle many more. And to achieve that, they have web interface settings to increase NAT sessions up from their default 150,000 to 300,000 or 1 million concurrent sessions, which makes them ideal for larger and busier networks. To expand on the VPN performance I just showed you, virtual private networking features are a core part of DrayTek's routers, and they enable you to connect 2 points anywhere in the world with a securely encrypted tunnel, providing transparent remote network access, only limited by the speed of the internet connections. Each of DrayTek's fiber routers support many simultaneously active VPN tunnels, which are needed more than ever with more users working from home, and it enables large and more complex networks spanning multiple sites, branches, and home offices. And for dial-in users, these routers also support many more connections. DrayTek's SSL VPN protocol is a great way for them to connect in and access resources such as remote desktop. This has the advantage of being able to traverse NAT easily, so it can work where IPsec and other protocols may not be forwarded correctly. You can get the Smart VPN client for free to connect SSL VPNs from Google's Android, Apple's iOS for tablets and phones, as well as Windows 10 and macOS. OpenVPN is another protocol used by all sorts of devices, and DrayTek's OpenVPN server allows any standard OpenVPN client device to connect. So one great feature that's unique to DrayTek's routers is DrayTek's VPN Matcher service, which we created in order to help with a common VPN configuration problem. This is available on all new DrayTek routers as a free service for the lifetime of the product. That common problem with VPNs going over the internet is that at least one side of the VPN needs to be directly accessible on the public internet with a real IP address. But what if both sides are behind another router's NAT, carrier-grade NAT, or using 4G connections? The VPN Matcher service allows both sides to locate each other, even behind NAT, so that they can communicate and establish a VPN tunnel. And this works for new DrayTek routers as well as the Smart VPN client with OpenVPN protocol, which allows remote dialing users to connect to your DrayTek router without a public IP address or port forwarding. Moving on to network management features. We can see here that a DrayTek router can be used to provide multiple separate networks using VLANs. Most of DrayTek's routers provide some VLAN functionality, but the fiber-capable routers take this a step further. VLANs can be ideal for large multi-tenant networks or large networks that utilize separate internal networks. They allow you to provide a fully walled-off guest network with access between a guest network, controlled with both interLAN routing and the router's firewall, so you have full control of what traffic can pass between these networks. The Vigor 2927 and 2962 support 8 and 20 networks respectively. And with the latest 396 firmware, the Vigor 3910 router now supports 100 LAN subnets, which is a task that is well suited to with its high session count and 10 gig routing performance. Another feature I'd like to mention briefly is content filtering. You can block keywords manually, but there's also advanced category-based web content filtering available with a subscription license. This lets you pick groups or categories as types of website you want to block. And upon access, sites are checked against these managed and constantly updated categories, so even new websites are correctly filtered without any manual reconfiguration. Now, looking at the guest wireless side of network management, we can hook up wireless access points like the new Wi-Fi 6 Vigo AP960C. This boosts speed and capacity so that wireless can't be a bottleneck for gigabit fiber broadband. And you can learn more about DrayTek's latest Wi-Fi 6 access points in our upcoming webinar. So to provide guest networks, DrayTek routers have extensive options for hotspot captive portal, provided from the router to both connected wireless access points and network ports for guests. This captive portal system allows you to show a branded landing page, which newly connected users will see before they can access the internet. Or the router can integrate with larger hotspot portal services, such as Purple Wi-Fi, with the router's hotspot radius integrations. And we can use a walled garden, or whitelist, to allow users to access specified sites like your company's website. Access to the larger internet can be permitted in a few different ways. Users could simply click through, acknowledging terms and conditions, or access can be granted with PIN code authentication, which users can receive via email or text message or social media. Each of these routers featured here today support this, with the option for logging customer access records to a secure database connected with USB storage. I should note here that this level of USB storage support is new to the Vigo 2962 and 3910 routers with the recently released 396 firmware. Now I'd like to talk about some of DrayTek's connectivity features. Each of these routers offer extensively configurable and hardware-accelerated quality of service, with app-based quality of service to easily prioritize important traffic for voice over IP calls, video chat, and gaming. So even the fastest internet connection can provide poor quality streaming and latency for gaming if it's in full use, basically, if it's fully utilized. So quality of service ensures less lag and better quality streaming for selected traffic, devices, or networks. And DrayTek's latest generation of routers have the performance to apply quality service to fiber internet access without throttling back speeds. Then we have DrayDNS. Each new DrayTek router is entitled to its own free dynamic IP hostname, which makes remote management and VPN setup easier when the WAN isn't fixed to a static IP address. And with this DrayDNS address, the routers use the Let's Encrypt Certificate Authority to generate their own trusted certificate for HTTPS management and SSL VPN. When the certificate expires, the router updates this without needing intervention. Then we have policy-based routing, which gives you full control of how and where traffic is routed outbound. With this, you can route select traffic through VPN tunnels, either to other routers or VPN services. You can lock specified websites to a single WAN interface, or route that through a VPN too. You can send services like DNS through a set WAN or to an alternative gateway on your LAN. And we can set up complex failover rules. So for instance, if WAN 2 is offline, select traffic can be sent through a VPN tunnel instead. With failback, we can specify how traffic is moved back to the main connection when it resumes. So for instance, does it need to fail back immediately? Or should it wait for all sessions on the backup WAN to finish first? If we're dealing with VoIP calls in progress, for instance, it would be best to wait and fail back sessions gradually rather than immediately. Policy routing allows us to control this failback option for each rule. Each of these routers provide great enterprise-level features too. For instance, we have BGP, or Border Gateway Protocol, to make managing complex networks spanning multiple routers easier. If one router has new routes added, this propagates to other routers in the BGP group. And unique to the Vigo 2962 and 3910 routers, we have OSPF, or Open Shortest Path First. So this allows groups of OSPF routers to autonomously determine the most efficient paths between 2 points, where there may be multiple hops connecting those 2 points, ensuring reliable and fast transfers in large multi-point networks. High availability is also available on each of these routers for hardware failover. This avoids having a single point of failure where even if we have multiple WAN connections available, a power supply failure could take the router offline and would completely disrupt connectivity. This is where we install a backup router that can take over as the gateway if we have problems with the main router. One significant benefit to Ethernet routers in this application over a router with an integrated modem is that two routers can share one DSL modem, such as the Vigor 166, with only the active router making use of it. So with two WAN connections and two routers, we avoid a single point of failure both for WANs and the network router. Now we'll take a look at some of DrayTek's management features. So for managing a single site, DrayTek routers can manage Vigor AP access points and Vigor switches. This aids in rapidly setting up networks, so you can auto-provision new APs so that they're set up as soon as they're plugged in. Switches can also be configured by the router, which makes it much easier to set up VLANs. And with the AC versions of the 2927 router, like the 2927 AC, you can manage 7 APs in a mesh group with the router as the central mesh route, providing both internet access and linking them wirelessly. You'll notice also that the Vigor 2927 can manage 10 switches and 20 Vigor APs, while the Vigor 2962 and 3910 can manage larger networks, supporting management of 30 switches and 50 APs per router or per site. Going beyond one site for multi-site management, all of your DrayTek routers, switches and access points can be managed either from the cloud or your own private server with Vigor ACS. ACS gives you an easy-to-use and clear overview of all your sites, networks, or customers' networks, with notifications and alarms sent by ACS as soon as issues occur so that you can drill down and troubleshoot network issues quickly with minimal disruption, potentially not even having to visit the site. Configuration changes like firewall and VPN setup can be sent to routers individually through ACS as a central point of management. And with Vigor ACS Cloud Premium, you can push changes to whole groups, sites, and networks at once with advanced provisioning capabilities. Vigor ACS gives you detailed records of both VPN logs and clients connected to each site, showing data usage and connection time per user, which you can search by time, IP, and the DrayTek device that clients are currently connected to. So with Vigor ACS Cloud Premium or self-hosted ACS, you can generate detailed reports with this data to find all routers, devices, or connected clients that match your selected search criteria. So that concludes the features portion of this webinar. Now we'll move on to your questions and answers, and I'll hand over to Alex now.
Thank you, Amy. Hopefully everyone can hear me. So yes, thank you very much, Amy, for that interesting presentation overview of all the different capabilities we have on the DrayTek Fibre routers. We hope you found that interesting. And we received quite a few questions during the presentation, so we've been replying directly to your questions, but I've picked out a few here that we can just kind of answer over the audio as well. But do keep asking questions because we can keep answering those directly, and also hopefully can pick some out for the Q&A section here. So the first question I've got that's come up was a question about whether or not DrayTek are planning to release any routers which would connect directly to GPON rather than using the network operator's ONT. So the answer to that is yes, it's something we're considering. There are some kind of considerations with that because with GPON, everything that's connected to the network needs to be correctly configured. So it's not something that you can easily allow a subscriber to just connect directly to GPON. So a network operator would want to control that. So it's something that we'd have to do in conjunction with the ISPs, but it's something that we're looking at potentially having kind of SFP type products that are able to have a GPON module in them. So that's something we're looking at. If anyone has any kind of interest in any kind of thing on that, then do contact us and we can kind of discuss that. But it's something that we might see kind of in the future. And next question is about for the home user. So a question is the 2765 suitable for use on FTTP? The 2765 is our kind of SOHO VDSL based product. So Amy, are you able to kind of answer that?
Yeah, so the 2765 series does have similar WAN performance to the 2927. So it serves as kind of our SOHO router both for DSL and fiber applications. So you can switch the LAN 4 port to operate as the Ethernet WAN port if needed. So you can use it with FTTP.
Okay. That's good to know. Thank you very much. And another question here is about NAT sessions compared to the 2862 series. So NAT session is the number of sessions that the router can cope with simultaneously. Normally these are in the kind of multiple tens of thousands sessions. So the older products, the 2862 series supported 50k sessions, and some of the other ones supported 20k sessions. So the question is, what do the current models support? So I'll just kind of cover that now. So we do 60k sessions on the 2927, 150k on the 2962, and 300k on the 3910. Although there are plans in firmware to increase that to a bit more, actually. Oh, Amy might correct me here.
That is actually already implemented in firmware. So with the 2962 and 3910, you can increase the NAT sessions. So 2962 can go up to 300,000, and the 3910 can go up to, I mean, this is kind of an extreme case, but 1 million sessions.
Yeah,
one thing to consider, DrayTek have pointed out that if you do set the session count up to 1 million, that you consider that it's mostly a sort of load balancing router. So some other services could be affected if you dedicate that many sessions to it. So
yeah, because it's assigning a lot of the memory. Yeah. So on the session, it's generally an individual PC will kind of use kind of a couple hundred sessions. So if you're looking at kind of 300 sessions, 300k, I think that's going to be able to cope with most sites. But for really heavy duty ones, that's where you might want to be able to manually increase it. So it's great that's now in the firmware. Thank you. We now have a question about VPN matching. The question is, can that work without a static IP?
Yes, VPN Matcher is designed to work without static IPs, and so the identification between the two is it's a matchmaking service through the MyVigor system. So, or DrayTek's a VPN Matcher service through MyVigor, and so that kind of makes the IP address of the client and server irrelevant. So it doesn't matter if it's on dynamic.
Okay. That's good. Yeah, it's really useful for often you kind of could get by with using host aims and maybe having one device on a static, but the VPN match just gives you that extra way of coping with different network environments and scenarios. So another question is to do with the SFP ports on some of the products. So the question is, are they fixed as WAN ports, or can they also be used as LAN ports on a network? I think people are thinking here of the question about the 2962 and the 3910.
Yeah, so with both of those routers, in fact, the SFP port on those routers can be used either as LAN or WAN, and it's not like a fixed block. So with the 3910, you can have one of the SFPs as a LAN port and one as a WAN port. Whereas the 2962's only got the one, so it's either a LAN or a WAN.
Okay, that's good. Looking through some of the questions, going back to some of the stuff about GPON, there's a question about whereabouts the splitter sits. So on GPON, there is a where's this question? Sorry, I've lost the question. It suddenly disappeared. So I can't find it, but I think I can repeat it. So the question is, on GPON, whereabouts is the splitter that splits the connection to the different properties? Is it kind of in the exchange, or is it somewhere else among the network? And where is that kind of physically located, kind of in the street?
Oh, that's to me, yeah.
Oh well, I can kind of answer. So the answer is it's kind
Thank
of
you.
as a node. It's in a similar sort of position as with fiber to the cabinet. There are these green cabinets around. The GPON splitters are in the street, but they're normally kind of in the docks. So they'd be kind of near the kind of group of properties that they're providing the connection to. So that's where it's split from, and then from there it's then running and to back to the exchange as one signal. So hopefully that answers that question. And I think we wanting to finish kind of in a couple of minutes, but I think we've got time to answer kind of a couple more questions. One is about wireless. So with GPON and faster speeds, the question is about what sort of wireless do we have now, and I guess the question is what sort of wireless would you recommend with some of the DrayTek products? Is it something you could answer, Amy?
Yeah, I mean, AC 1300 wireless will be able to. I mean, technically, sort of the real throughput you'd see with AC 1300 will be maybe sort of 600 or 700 megabits, so that could be a limiting factor in some cases. But with the AP960C and upcoming AX products, the wireless performance goes to AX 1800 with, real performance easily saturating a gigabit connection pretty much. And more. So that's definitely something to consider. And also, if it's spread over multiple access points, of course, the more users you've got, the less you have to worry about that, because the WAN throughput will quickly become the limiting factor versus the wireless radios.
Yes, and we've got a presentation, I think, on our kind of next generation wireless stuff as well. So there's another webinar coming up this month. So do look out for that if you want to attend to find out more about Wi-Fi 6 and DrayTek's product range. Would also, in due course, have some routers as well that have AX capability in them as well to complete the whole picture on that as well. And I've got a question here about a kind of upgrade scheme. If there's any plan for DrayTek to offer an upgrade scheme for customers moving from FTTC to FTTP. The answer is we don't have anything currently yet, but it's always something we could consider and look at. One of the things that you do benefit from if you've got something like the 2862, actually its WAN throughput is in the kind of mid number of hundreds of megabits per second. So for a lot of FTTP connections, it still could be viable depending on what package you've got from the ISP, because it has the WAN port on it. So that there is an option there that you could potentially, in some cases, use something like the 2862. But yeah, for kind of upgrade paths, we might be able to look at some sort of schemes in the future, but it's not something we've got anything announced or currently planned. So let's look if there's any other questions. I think I've covered most things now, so I think it's be a good time to close off. And thank you everyone for answering your questions and for attending. And we hope you found this presentation useful for you.
Thanks.
Thank you and goodbye.